All right, welcome back. So we're now at the fourth episode of the career development interview for EE323 at KAIST. Hello again, my name is Sungju Lee. I'm a professor here at KAIST, and I'm super excited to welcome Dr. Riccardo Crepaldi. He's a staff software engineer at Google. I'll let him introduce himself, but Riccardo actually interned at HP Labs when I was there, not once, but twice. After the first suffering, he still came back. So he has very high endurance and tolerance. We actually did some interesting works on MIMO and developed something called CSISF, inspired from the TV show. Since he got his PhD, he moved on to Google, and I discovered that he's been working on really interesting stuff for Google Cloud and networks. So we'll hear about that today. So welcome, Riccardo. Could you say hello to the students and others who are watching this interview?
Yeah, thank you. Thank you for the nice introduction. I have to admit, I don't think I've been called doctor for years. So it's a nice reminder that I was a student in a previous life, and I started my career in Italy. That's where I was born and lived 6 years. That's where I did my bachelor's and master's. As a matter of fact, back then in Italy, we didn't have a bachelor, so it was just a 5 years program to get a master's. And that was in electrical engineering with a concentration on telecommunications, wireless telecommunications. And then I moved to the US to pursue a PhD in computer science, also focusing on wireless networks at Urbana-Champaign. And as you mentioned, that's how I got to explore a little of the industry world, IBM research, and then HP Labs. And then when I had completed my PhD, I came to Google. Google is the first grown-up job, if you will. Yeah, it's been a very fun ride ever since. I've been at Google for 8 years, and I've always been in the same organization called ENPRA, stands for Engineering Productivity. And if I have to summarize our mission in one line, we try to make Google engineers as productive as possible. I'll tell you more about that, what that means later. The beautiful thing is that when I joined Google Cloud, that just started, we had barely any customer or any big customer. And so even though I stayed in the same organization for 8 years, my job keeps changing and it keeps growing and keeps both being interesting and giving me opportunities to grow.
So you mentioned about you're interested in wireless, and that was your, concentration in your, undergrad/MS joint program. So did you know from the first year in college that you were going to do wireless networks, and how did you get attracted to that subject?
I knew I wanted to do networking for many years. I was fascinated. I didn't know that such a thing as distributed computing existed, but I knew I was fascinated about the idea of two machines talking to each other. You can imagine when I was growing up, two machines talking to each other meant, if you've ever seen War Games, the famous movie, it really meant that. It meant taking a phone and placing the phone next to the computer and hearing noises that made no sense to you, and two machines would be able to communicate. That was really fascinating to me. And so when I had to choose my concentration, I thought telecommunications was great. And there were two options, optical communications and wireless. And optical had a lot of really, really theoretical physics that I felt I didn't quite enjoy as much as seeing things working. The beautiful things about wireless networking is that with a spectrum analyzer, you can actually see the packets on a screen. You can see the electrical signal oscillating, and you can modify, tune it. And that was really interesting to me.
So I think students these days, at least in Korea, they grew up in an incredibly pressured environment, and they're stressed about getting really high GPAs, right? And I was telling him, good GPA might get you an interview, but once you get there, right, it's your skill set, right? And some students try to avoid difficult classes to get high GPAs. But like,
Yeah.
what would be your advice? Like if you want to ace a Google interview, right? What kind of skill sets do you need? Are there certain like courses that you recommend, like data structures or operating systems, those kind of stuff? I mean, do you have some tips?
Yeah. As a matter of fact, I serve in hiring committees. I've been serving in hiring committees for years. So I see a lot of new graduates packets. What You're absolutely right. GPA actually doesn't quite matter. And don't get me wrong, a good GPA means that you're a good student. So aim for a good GPA because that means you're doing well in school. But I don't look at the GPA on a resume. And what we look instead is what courses, what experience the student has. What's really important, for example, was what practical experience. A student that throughout their career has had a few internships or maybe just some side projects. If you have a GitHub repository where you have your own personal projects. These things give me, a window on your technical skills. And then, of course, it's your performance during the interview. And the interview is focusing on checking a few aspects of your abilities, technical competence. We tend to hire generalists, so we don't hire you for a specific position. So it's uncommon that I would be asking you, I see that you have a networking class and I would be asking you about networking specifically. It's much more common to ask general software engineering questions, algorithms, data structures. The reason for that is that we promote internal mobility a lot. So I may hire you for a position right now, and in a year time, you might be working on something completely different. And so we want to see that you have the fundamentals, that you know your algorithms, you know complexity analysis, you can make decisions. That's the key differentiator, given that you can solve a technical question. Like there's many books out there, Cracking the Coding Interview or many others. There's Glassdoor, Career Cup, you can find problems. Given that you can take a problem like that and write the code solution, what really makes the difference from a good to an outstanding candidate is if you can offer multiple solutions and show me trade-offs. Things that I like to hear is when a candidate says, okay, you're asking me to design an API that has a read and a write operations, but how will the user be using it? Will it be a million writes and one read, or a million reads and one write? Because that's going to change how I design my structures to optimize for one or the other. It doesn't matter what the choice is. It's really knowing that you're thinking that way, that you're thinking of how your thing will be used, and that you realize that it's not the optimal solution. Sometimes it doesn't exist. It's the optimal for the use case. It's really important. And other things that practice really helps you with is testing. It's really a great sign if a candidate doesn't just write the code and says, I'm done, but shows me you understand you need to test your code. You need to be looking for ways to break it. This kind of practical experience is really important.
Right. And one thing I might add is also the candidate has to communicate their thought process while solving the problem, right?
Right. So that's another very common pitfall. Everyone hears that. Everyone hears you have to be talking while you're coding. Some people understand that as in reading your code. And so you will go through your code and will tell me, for I equals 1, for I that until I becomes greater than 10. I don't need that. I can read. What I need to hear you saying is, I'm looping through my list here, and this might be linear, but later on, I'm thinking that I could do a bisection. This list is sorted. Talk to me about the important things that you're not writing, and tell me what you're thinking. And there's a double advantage when you do that in an interview. As I was mentioning before, we are not here to trick you. We could actually help you. If I see that you're stuck, I will try to get you unstuck. But if you don't talk to me, if you don't tell me what you're thinking, I don't know that you're stuck, or I don't know what is getting you in trouble, and I cannot help you. So it's really an advantage. And the way you get to this point where you are very good at this is to practice, 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 and practice with your friends. So the great thing about working in a very large um, program like UIUC was that I could practice with tons of friends that were interviewing at the same time, and I highly recommend that.
Right. So you should also have friends.
You should oh, I mean, by God, uh, college first and foremost, make friends, then
Yeah.
study.
All right.
No, it's important. I mean, your connection. It's I didn't realize it, but the people I was friend with in college, I keep bumping into them at work, in technical conversations outside of work, conferences. It's really a small community.
Right. Right. So let's go into life at Google. I think this is a topic that students are most interested in because obviously a lot a lot of software companies have caught up, but Google's basically the pioneer in employee benefits, working environment, perks. What are some of the things that you could share that some of the students might not know of?
Well, first of all, I think I should confirm, yes, we do have free food. Yes, we have the game rooms. We have concerts. We have the massage chairs, the nap pods, where if you're tired, you can go. Every year, you get 60 minutes of massage from a professional massage for free, and you can buy the rest if you need more. There's a swimming pool outside of my office, gyms in every office. All of that is true. You have it, etc. First years, I think that's great. That's almost sufficient. As you grow, I think you start using less of those resources. It's still great to see them around, but you start being more busy and having less time for a pool game in the middle of the day. Uh, but I think there are some other perks that really continue to be great. Certainly, the support we have, uh, the sick policy, for example. I can take any sick day I want for me or my family. If my children are sick, I don't need to tell anyone anything. Just stay home, put it in the system, and say I'll be back when my children are better. The health insurance, I don't know how the health system is in Korea, but here, having a good health insurance is really important for your family. And a lot of those perks. Plus, there's the amazing things such as if you are in a remote country and there's a earthquake, our security team will work with you to evacuate you and your family. It seems remote, but I know friends I have a couple of friends that were on the Himalaya when the earthquake struck back in 2017 or whatever it was, and Google sent a plane to evacuate them. It happens. Uh, More common, things that you will experience every day. That is great. Google has an open access policy to almost everything. I get access to design documents of most of the products. There are only very, very limited areas of the products or the code that are secretive. I get access to the source code. I can make changes to the source code of most of Google products if I want to. And everyone is very open. So if you have a question for a very high level engineer in a product, you just schedule something on their calendar and they'll be there to talk to you and answer your questions. And of all things, I think this is one of the best perks.
So I mean, it sounds like it's a company that not only cares about professional growth of each employee, but their well-being, right?
Correct. Yes. I mean, they are tied, very tied to each other, right? If you're happy,
Right.
you are productive, and you're also a loyal employee, if you allow the term, right? You're someone that will really try to do best for the company, and because you feel like you're a part of it. You're not just working because you want the salary. Another perk that I took some notes here. Another perk that I should have mentioned. We have this policy of dog fooding. I don't know if it's a
Yeah.
term that I've thought of, right? Eating your own dog food. It means before you launch something, try it yourself, and that means that I have access to so many hardware and software products that haven't launched for a year or two before they launch. Sometimes they never launch because we do cancel a lot of products.
Yeah.
So at home, I have 7 or 8 Google Home devices and didn't pay for any of them.
Hmm.
They don't work most of the times because they're running test software. But when they do, it's fun.
Now let's talk a little bit about work.
Yeah.
So, so actually a very good question from a student of mine. So she actually said, when I read distributed systems paper, right, like especially if it's large scale, uh, it's not easy to understand all the details because not many students would have experience dealing with or managing such systems, right? But it's really important in the systems. One details is important, right? You miss that detail, the system doesn't run, right? So I mean, you feel like you're kind of stuck, right? So I mean, did you have such experience, as a grad student or even as a professional? Like, how did you overcome it? And now that you're at Google managing this, gigantic networks and cloud systems, what kind of knowledge and skills do you think one should have to design such systems?
Mhm. I have very, very good questions. So first of all, absolutely, I had that feeling all the time as a student, especially obviously in my first years. But in general, you go to conferences and you hear these people talking about the research and you understand 25, 30% of what they're saying, and you feel so out of place until you realize they've worked months on that research. They know it inside out, and that's why they look so competent on it. And you're hearing about it for the first time. So obviously, there are things you don't understand. Um, I was reading this question yesterday, and I was reading a paper, I don't an article, sorry, a newspaper article that for some reason was citing Leslie Lamport,
Mm.
uh, and that made me think of the perfect answer to this question: how do I understand, even though I don't understand every single little detail? I think the key, especially in distributed systems, is understanding the problems, not the solutions. If you understand, I hope you know who Leslie Lamport is. If you don't, go and read the
Go
Lamport.
Google it, right?
Go Google it. Lamport clocks, Paxos. Paxos is one of the reasons why Google exists. Um, you don't have to understand or remember how the solutions work. You need to understand the problems they were trying to solve. The Byzantine failures, the impossibility of reaching consensus, the ways distributed systems synchronize themselves because they cannot have a perfectly synchronized clock, and the problems that happen when your clocks aren't synchronized to the femtosecond, right? You understand these problems, and then when you want to read the solution, you go into the literature and you look for the specific solution, the specific detail, when you know that you're facing that specific problem. Uh, so that is my first recommendation. When you're reading a paper, when you're reading something, don't struggle to understand the solution unless you can pinpoint the problem and describe the problem in one sentence. And that then comes useful when you're writing your documentation, because that's how you write good papers and good documentation, is by describing your problem first, or how you expose your dissertation, right? Um, so yeah, that's one thing. Did it happen to me at Google as well? Yes, the first 6 months, my entire time in meetings were trying to understand the words I was hearing, what they meant. The first 3 months, I just felt stupid. I'll be honest. Google has this thing that everything is internal. Everything is built internally. We don't use Git. We don't use Jira for bugs. We don't use any of the external tools. We build everything in-house. So names are different, and the first 3 months you just hear names over names and you don't understand them. The next thing, that's what I think saved me and gave me the kick to start making my progression, was understanding the things I needed to learn and the things I didn't need to care about. There is too much information, and if you're drinking at the hose and trying to understand everything, you will never be able to contribute anything. So the key is, when you are facing a new area, is understanding the domains of this area, the boundaries, what you need to understand. And that keeps going. Just yesterday, now my work is more on the horizontal scale. In a day working on the projects I work on, I can have a conversation about firmware and a conversation about the user interface of Google Cloud, and everything in between. Right? Yesterday, I was in a chat where someone was trying to perform a specific operation and it was failing. And for 4 or 5 times, I tried to offer solutions. And every solution, and these people were junior. And every solution I offered, they were like, yeah, no, already tried, doesn't work, here's why. And at the 4th time, I realized, you know what, these people know what they're doing in their domain. I don't need to be an expert in their area. They are the experts. Let them do it, move along, look at the big picture, look at how the components fit together. That's my role. And let each individual be an expert in their area. And so, yes, there are still a lot of things that I don't understand about the individual components. I just ask the questions when I have them. But what I understand and what I think is important to understand is how all the pieces fit together to get wherever you want to go. Faster networks, more resilient virtual machines, whatever it is.
So thank you, Riccardo, for your time. And I think you gave a lot of good technical insights, but also advice for students as they're developed. Can you give us some concluding general advice to the students?
If they are approaching the decision of what to do next, I think really go with your passion. Don't focus too much on what is the next big thing, because you may not be a good part of that next big thing if you don't do it with passion. So really understand what you like, and to do that, you just have to take every experience and opportunity. So if you have an internship, if you have an opportunity to work in a research lab, just take them. Don't worry if it's the best thing for you. If it's new, it's going to teach you something. If they're looking for being successful in interviewing, practice, practice, practice. If someone is thinking of interviewing at Google and want to know more about the interviewing process, feel free to reach out to me. I'm sure SJ will know how to reach me, and I'm happy to give you insights.